Local walk-in customer that just came from the Apple store. So what's your name?
Mark Shaver in Victor, New York.
Mark Shaver?
Yes.
Did you know that Mark Schaefer is my right-hand man and fantastic employee here at iPad Rehab?
Awesome.
Isn't that funny?
And are you the boss?
Yes, I'm the boss. I'm
Okay.
Jessa. Yes.
Okay. And we have Emily Shaver hiding over here on the side.
She's not here. No. Maybe she'll come to join us. Live stream is generally pretty fun. So let's see if we can get some feedback that we are live on YouTube. Let's just go check. Let's go check over here and see if this is streaming today okay or not. So let's see. We'll go to iPad Rehab channel. All right. So okay, somebody can see us. All right. So we're streaming live to YouTube and Twitch. All right. So so this one, I'm really happy with what Apple said to you. So you got up this morning and went down to the Apple Store because you've got an iPhone 5C here that doesn't detect headphones.
Yes.
And so you go down to the Apple Store, makes sense because they made the phone. So we'll kind of test that here. So we'll play a video. You got any cool moves? All right, so and you're saying that this has kind of a sweet spot, and it feels really loose.
Yeah, it's a loose connection, intermittent connection.
Yes, so that seems pretty classic. And if you compare that to what this is what the dock connector, the charge port itself looks like. So it's a piece like this, or you can touch it. And see how it's got a little place where the guy plugs in?
Right here.
Yeah, exactly. So even on this one, it makes that satisfying click.
Mm-hmm. Yep.
All right, so yours is not doing that. So that seems you're an electrical engineer.
Yes.
So this is pretty obvious break fix damage, and there's no real likelihood this is going to be anything other than just the charge port of the dock connector. Probably, most likely, we'll find out. So you went down to the Apple Store, and what did they say?
They said that's not a repair that they would routinely do. They offer to trade the phone in and buy a new one, that sort of stuff. But
so is that $279 for a 5C from them?
It was more than that. It was
really?
In the 300 something range.
$300 for a 5C. That I mean, that's what's insane to this. This part is sense exactly, yes, sense.
So, but
Christy, can you help up front? Christy, are you here?
Yes, I am.
All right.
But the guy was pretty good. He said there are people around.
Awesome, that is great.
That would repair this. He recommended we not do it in a stand in the mall or anything like that. He said you want to go to a place with brick and mortar. Mm-hmm. And then he named your place, looked it up on the internet for us, and wrote down the contact information.
That is great. Good job, Victor Apple Store. Good job. That is how I would love to see this sort of general relationship between independent repair and the OEM manufacturers. There's nothing wrong with them saying, like right now, this phone could have water damage or, who knows, all sorts of things. It would be difficult to warranty it if it did, and I can understand them sort of just making a business decision that says that's just not something we want to train our technicians to be able to diagnose and troubleshoot at that level. There's nothing wrong with that. And in the past, our experience has been that, in general, they say it can't be repaired. And they didn't do that this time.
They didn't say that.
That is great.
In fact, if it had been in warranty, they were going to repair it or replace it or do something. And
right.
They were very clear that there are people around who fix that, and that's the business they do.
Great job, Apple Store. All right.
So we were pleased with that. And
me too.
You're not too far away from where we were and where we live, so.
That is great. I've been banned from the Apple Support Community Forums, which is their online, like if you were to Google, he's like, really? And maybe we should go.
No, I'm
saying things like
I'm in the business, so I get that stuff happens.
Yeah. So I got banned for saying things, for specifically this exact problem, where someone would have obvious damage to the external facing charge port or a headphone jack or something like this. And this is kind of a classic example of what is really kind of a straightforward thing that traditionally, the Apple organization as a whole has just said, you know, you can't go to these unauthorized people that don't know what they're doing. You got to stick with the Apple repair, the Apple in-house repair, and that really kind of stinks for the end consumer because they don't do it. They don't actually do the repair. Now this is cool. See how this screw is not magnetic and all the rest of them were? That one I wasn't the magnetic end of the screwdriver. That one goes on top of the compass chip.
Now, why would they make that one not magnetic? It's longer than the rest. I see that.
It is, yes. That's a good observation. If you're doing your
it,
DIY screen change, you can't mix those up.
Is that a special screw?
It is, because it is the location of the screw is at the compass integrated circuit chip.
I see. Okay.
And so I assume
not
isn't that clever?
Yeah.
Isn't that clever? All these sort of little things. All right, so we can read some live stream comments and see if anybody wants to ask us any questions, and then ultimately live streams turn into videos at the end. So, so this guy's in Australia right now. Pretty sure Paul Daniels, Australia, right? Somewhere where there's a bunch of like kangaroos walking around. All right, the gang's all here. All right, yeah, there you go. The Apple in-house raping, aka Tier 4, $700. So I got banned from the Apple support community forum. We're going to look under the microscope now at your phone, and it was for saying things like, if you're under warranty, you should definitely go to Apple. But if not, then go to independent repair. Replacing a charge port's a straightforward job. And the guys over there at the forum, they will not allow posts like that to persist. Was this a refurb?
I don't know what you mean by that.
Is this something you bought at like the Verizon store?
No. This has been replaced once, right? Though, Emily.
Yeah.
What was the problem before?
What do you mean?
We had this is a replacement phone, isn't it? It was replaced under warranty.
I believe so.
But I don't remember what the original problem was. But no, it was a brand new phone.
Right. That mark, it's like marker paint. So this was this replaced at Apple?
Yes.
Yeah, so there's like a weird sticker under there, and this mark, and this sort of just the appearance of this logic board. See how there's like a piece of green something there? That's atypical. And this sticker, this doesn't look like as crisply never been. I'm not the first person who's ever touched this logic board. Have you ever opened this phone?
Nope.
Yeah. So that is pretty classic for things that Apple does. There's nothing wrong with that. But they would, let's say that you actually turned this phone in today and said, okay, fine, I'll do the $379 replacement. Then they would say, okay, so you would turn in your phone, and then they would sell you then one in a white box from off the shelf. But for a 5C, that's going to be one from the last guy that turned it in.
Right.
And then they send it back to the mothership, which is in Texas, and somebody else would do this job, then package it in the white box, and then they're going to sell it to you for $300. And so that's probably the history of this phone itself.
I would say you're absolutely right.
Yeah, so we can see the speaker.
It's like Sears when I take my
Look, you're missing a screw.
Like we got screw loose?
You got a screw loose. See up there? You see how the dock is plugged in with a screw here? There should be an identical screw in that hole. So you're just flat out missing that screw. And then we can see some, kind of discoloration on the speaker itself, which is not really terribly atypical. And let's see. Yeah, you're missing a screw. That's all right. We'll
That's what's causing the audio jack?
No, I don't think so. This audio jack is pretty secure. So this is the inside part where you plug that thing into. So if we plug in some headphones, you can look up on the screen, see how it plugs into there. And this is just a plastic piece, and this is what it looks like. You can touch that one. So it plugs into right there. So we're going to replace that whole piece, which then we'll see if that solves the problem or not. Alrighty.
So it's been to their repair place.
Yes.
And then This was originally somebody else's phone, brand new.
Right.
They had a problem, they brought it in.
Yep.
They sent it to the repair place, it came back, and then when Emily took her phone in, they took her phone and gave her this one in return.
Yes.
Under warranty or
Yes.
something like that.
Yes. Yep. I mean, that's really what repair is to them. It's the they do things like this. They're not going to throw away a phone over this piece. So they've got a crew of guys in a very limited number of locations that they ship these to, who will then refurbish them, and then they make it back into the white box and go back on the shelf to be sold to the next guy. And they don't use the word refurbish, and they don't use the word, they won't say not new or anything. They'll say remanufactured.
Yeah.
So this is a remanufactured phone.
And are those repaired by Apple employees?
Yes.
So why wouldn't they contract that kind of stuff out to you, or places like yours here?
That is a very good
I
question.
mean-
That's an excellent question. Why wouldn't it make sense for them to just say, hey, why don't we make a formal relationship
Yes,
with you, so that at the
exactly.
local level? I mean, that seems like it would make a lot of sense. And I don't know the answer to that, but I could guess, and just from my experience, I could apply to become an Apple authorized service provider, and if I did that, I would not be able to do this job.
Yeah, they would.
They would not
They're gonna-
allow
they're gonna
even
impose
the
restrictions on you.
Apple authorized service provider. So in order for me to get that status, I would have to meet a lot of very specific criteria. For example, signage, parking, overall look and feel of the shop. And this specific job, I would not be authorized to do. They wouldn't trust me to be able to diagnose and to turn the screws to change this port. So I would be required to just take the device in, fill out the forms, put it on maybe something like a USB meter and, confirm it's not charging or whatever kind of simple diagnostics. And then I would mail it to the Apple Store. Even something as simple as a battery replacement. So look at how your phone is half of your phone is battery. And then this is sort of the heart and brain of your phone. So to replace that battery, I mean, this is really cool. These things have these little pull tabs. So if you took a tweezer there, it would be like one of those 3M strips that you just sort of pull out, and then the battery would come out. Easy to replace. Now, if I was Apple authorized and I were to pull that little command strip, and let's say that it tore halfway off, I would not be allowed to take a tool like this and then just kind of ease that battery out, because that would be now off the very tightly controlled protocol of how you change a battery. And so if I had told you, sure, 10 minutes, I'll get your battery swapped out, then in reality, I would have to go back and tell you, I'm sorry, I have to send it out. It'll be 5 days. So come back in 5 days. You got to live without your phone for 5 days. That would not be fun. And so that's what Apple authorized repair looks like. So the idea of them, I mean, that's already what they're like. The idea of them kind of going beyond that and actually allowing individuals to do repair, it just seems way out of their comfort zone for what they're okay with letting people do. So Merrick says that phone was brought in by Apple. No, this phone was brought in by Mark, and he is a local resident from one town over, and he went to the mall Apple store. So we're lucky over here. We have an Apple store that is very nearby. So these guys went down to the mall, went to the Apple store, and I have to say kudos to the Victor Eastview Mall Apple store today, that rather than telling these guys their typical line, the same stuff that I get banned from the Apple support community forums all the time, rather than saying, yeah, we can't fix this, no one can, your only option is to replace out of warranty this phone, $300. These guys told you guys, you know what, why don't you go down to iPad Rehab, they're, one town over, and they can probably do it. So good job on the Apple store in Victor Mall. And that's exactly the change that I'd like to see in this industry overall. There's nothing wrong with Apple choosing not to do repairs like this, but it's in their consumers' best interest to get the headphone jack replaced rather than have to, toss the phone or live without it for a long time. Alrighty. Let's see what else is going on in chat. I wonder if the store is going to get into trouble. We'll find out, won't we? I hope not. I think if they did, that would be incredibly douchey. But honestly, what do you think? Do you think the store is going to get in trouble? Do you think somebody was going outside of policy?
I doubt it.
I don't know. I mean, if they are, then that policy really should be changed, in my opinion. But what do I know? I mean, we get a lot of referrals from Apple stores all over the country, mostly for data recovery, and we've gone down to our Apple store and just kind of let them know who we are and told them, you know, for the Apple Store genius there, when you've got a mom crying because her baby pictures are trapped in this phone and you don't have any options for her, you can kind of get out of that situation by telling her to come down and, you know, send them over here. So it really kind of works out for everyone. All right, so we are going to take this, continue taking this apart. We're just going to get a little bit of clearance there on the logic board. Ben Duffy says, check the model number when you're done. Curious to see that first letter. All right, where do you want me to look for that, Ben? I know you're into the whole refurb letter thing. Do you mean on the IMEI, or what are you talking about, Ben? Ben is also in Geelong, Australia. So it looks like Australia is up this time of day, I guess. All right, so let's see whether or not we're ready to get that out. All right, so I'm going to put a little bit of heat on the board at low heat to just sort of soften up this adhesive. iPhones really are just kind of Lego projects. They're not any different than anything else you might fix. So what do you do? So what kind of stuff do you do all day before you were retired? I mean, now fishing, obviously.
I designed and built machines that manufacture in plants. So I was a automation electrical engineer. So I designed the electronics, the controls, write software that controls the machine, write software to be the user interface, you know, the graphical user interface, all that sort of stuff.
And did you do that for Delphi?
No, I did it for a mobile chemical company.
Okay.
Which is now ExxonMobil. And then the division was sold to Tenneco, became Pactiv, and then for the last 10 years I worked for Pico Precision Products in Rochester, New York, who's a custom machine design and build firm. So we built machines, custom manufacturing machines for other companies like Fujifilm and Kodak, Xerox, et cetera, et cetera.
Yep.
So
well, that sounds pretty cool.
We'd build the machines and then we would...
so do you know how to program a CNC machine?
Not directly. I know how to repair them. I occasionally got...
Repair, awesome.
Occasionally got called on to repair them.
Oh, yeah?
I mean, I know about programming. I know about the G codes and M codes and all that sort of stuff, but I'm not... I mean, I couldn't take a drawing and then program the CNC machine, but I know...
Can you make that CNC machine back there stop squeaking when I hit extract the thing? I mean, I already tried WD-40. I don't know if that's what your go-to tool is. That didn't work.
WD-40 is good.
Yeah? Do I need to get a certain kind of lubricating oil?
I don't know. I could look at it.
Great. Awesome. Yeah, we love all kinds of repair. Yeah, so we got, I mean, it's really cool what China can do. So China has made, you know, that machine back there, which you can put one of these boards on it. And let's say that you needed to drill out a chip like this board I've been working on for data recovery here. There's all these chips that we're replacing. Some of them are difficult to remove. So, for example, the CPU, if you just use the CNC to elaborately drill that chip down to the pads so that it would look like this.
Yeah, you're machining it back down to the original
right,
pads.
exactly. So that sometimes is a good option when you have that just really, really tight clearance to other chips and things like that going on. So we got that machine a while ago. We rarely have reason to use it, but it's kind of fun. All right, so we're going to take out this piece. This is your speaker itself. So that thing is your loudspeaker. And we're going to stick it in the surgery tray. And then we're kind of down to the level of the actual port itself. Now these have a little plastic or a little bit of a housing piece that we're going to transfer over to your new dock. So this piece here, and this is one of those things that's kind of like the difference between maybe a shop that's got to have a high throughput and get people in and out the door. Tiny details of transferring this this, whatever you call it, spongy piece here from your old port to the new port, which is not going to have that piece. There's a couple things you have to kind of retain, and that is what would make the job difficult if you were Apple, because to get it back to design, in theory, you would need to train people to locate and remove that safely and not tear things, and I can see that that would be difficult, especially when they can't get the guy to even put that screw back in. Then I can see that would be kind of hard. So these things are complex. They've got, and they really do kind of vary in quality, so you can get bad ones as well. And what makes it difficult for us is that we have no way to buy from Apple itself this exact port. So we have to kind of do a lot of legwork to source these parts where they come from in China, from sort of fell off a truck, parallel supply chains. And there's just a lot of legwork that we have to do to make sure that we're getting the same quality parts as would have been in the original. All right, so here comes this out. All right, so there's your port. We'll stick this back over there. All right, let's turn it on its side and see if we can see inside there. So I'm not sure we can get a good view with this lighting. It just kind of looks worn. So typical, made of plastic. That's just the way it is. All right, so now we're gonna rebuild. So we're gonna get out your new.
So are the mechanical detents that snap into the rings in the plug, are they plastic? Do they just wear out? Is that the?
I think there's the thing that it actually touches, I think, is metal. See, it's hard to see. Can you see that?
The contacts would be metal, but
right.
The springy thing might be that it's just plastic eventually.
Yeah,
it's good for 10,000 insertions and removals.
Right. Yeah, I think that's the deal. Here, feel free to examine. All right, so let's look at this new one. And before we install it, we want to take a look and see if we see any kind of signs of obvious problems. Yeah, so look at this one. Yeah, it's absolutely just a flat plastic bottom. And at the bottom, there are metal springs that kind of clip this thing. That are pretty easy. You can see it a lot better under the microscope without going through the camera. All right. Okay, let's see. What's going on in chat? This guy Rodrigos says, we can learn a lot about this guy. Pull a schematic and ask him. Yes, we'll put you to answer all our questions on schematics. All right.
Okay, this will be Emily's mom.
All right.
Wondering what the heck we're doing.
Tell her to go on iPad Rehab YouTube channel. That would be pretty funny. All right, let me look at this other one. Yeah, so look at these parts here. So I have two that are ones that I could install. So let's compare them to the original. So both of these are parts that you could order from China, and they probably would both work. Let's look at this one though. So if you look at just the detail of it, this part is kind of not my favorite. If you look, it almost looks hand soldered if we look at these joints. See those joints there? Mm-hmm. Right there?
Yeah.
That is not, I would probably fail that if that was one of my students. And it's got the chip on there, but this just kind of overall impression looks like it was done by students. And that's sort of the picture that I would get on there. And now let's compare it to this one.
Now, who would your students be? Are they
my students
trainees that were going to work for you, or
I train people that would be folks like people that are on YouTube here that would come out here for 5 days to learn how to diagnose and troubleshoot board level problems on iPhones. And so they have to do a lot of soldering. Now let's look at this one. So this one has a protective whatever that stuff is. It seems to be kind of like silicone or hot glue, and I don't know. But look at that. That's a lot more professional.
Yeah.
This particular job. So even though, you know, when you kind of hold these things in your hand and you say, it's the same, it's a brand new charge port, either one of them is going to work. That's what's really difficult about this industry is the difficulty in sourcing quality parts. And we'd like to be able to just have the Apple Store sell me this, and I would pay retail pricing to them for that, but they will not do that. That is definitely not okay. All right, so let's get this one in. So we'll peel these stickers. We'll give you the good one. All right. Yeah, it's tough. You know, there's just so much competition in China. All right, so we'll get busy here.
So it's very obvious to me, being an electrical engineer and all in this
Yep.
similar business, that you're very experienced specifically on iPhones and that sort of stuff.
Yes.
You know your way around this. You're not having to record what order you take stuff out. You know how it's going to go back in us.
Yes.
So how did you get to that point? How did you get started in this?
Well, I am a firm believer that the internet can teach you anything. So I was my story is kind of classic in the industry now. So my story is that I have a PhD in molecular genetics from Johns Hopkins and came up here to teach at RIT for a while. And then I had 4 kids, which is about 2 kids too many, so I don't recommend it. And then my 4 kids started breaking iPhones and iPads, and I was a stay-at-home mom at the time. And so I said, well, you know, how hard can this be? And so I started to attempt to fix these. So I need that one back for me so I can transfer over that piece.
It's right here.
Ready? So, you know, they started breaking them, and then the thing that really kind of was transformative for me is that I had an iPhone 4S that my twin daughters, who were 2 years old at the time, threw in the toilet for me.
Gosh.
Yeah, it was like 2 weeks old as well. It was super annoying. And, you know, I didn't know it was in the toilet for a day until I was a heavy user of the Find My iPhone app.
What?
And they told me that, you know, toilet's clogged, Mom, it won't flush. And then I finally pieced it together that, okay, that my phone was what was making the toilet clogged. So that was kind of a drag. So I did what anyone would do and tried to get it out. Pipe auger didn't, you know, plunger didn't work. The auger on the drill thing didn't work.
So it was a 2-year-old that did this, right?
Mm-hmm. 2 of them. Mm-hmm. And so then...
Yeah, just keep phones out of reach from
yeah, exactly. That's right. That would be a good life lesson. So then I said, hey, Internet, how do you take a toilet out? Oh, it's pretty easy. Just turn off the water and unscrew the 2 things, lift it off of the little wax bracket. So I did that.
Drain the water first.
Yeah, drain the water. Good. You've done this before.
I said my dad did it.
Oh, your dad did it. So, well, I took mine out onto the front lawn, and then I did what else anyone would do, which is to have the kids come out and take pictures, because that's hilarious. and then I...
Wow.
Yeah, and then I smashed it with a sledgehammer. As anyone would do.
To get to the iPhone, or just
To get
because?
well, both, you know, because
Oh.
I really couldn't get it out, and I wasn't 100% sure it was my iPhone in there, and by then I'd had it.
Was it
So-
like a glass toilet or?
No, it was easy to smash. They're surprisingly easy to smash. It was a ceramic, I guess, porcelain or whatever that stuff is, toilet. So I smashed it, and there was my phone. So I did get my phone out.
Hopefully
and
it didn't break.
well, that was the thing. So I was, you know, dumb enough to do what the internet tells you and put it in rice, which, you know, no, I never. That's never a good idea. The corrosion that happens is surprisingly instant. Whatever chemical process that is, when hot electrically active board meets water, you can watch this in real time. I've done this a number of times. Pitched phones intentionally into water, and you know, like instantly.
Molly wants to like accidentally dropped her phone into a toilet in the Outer Banks.
Yes, Molly, Emily's sister, dropped her phone in a toilet at
Mm-hmm.
a rented house in North Carolina at the Outer Banks, and put it in rice. And I think it eventually worked again, didn't it?
And I think
it did dry out. But
I think I remember something Joe made a joke about it. It said something like, you should put it in the microwave, put it on high.
Yeah,
Yeah, that goes around. We've seen a few of those.
Yeah, my son is also an electrical engineer. And
Okay.
he said, I know what to do. Put it in rice put it in a bag with rice.
Right.
Put it in the microwave on hot. Make sure it's on high.
That's a great plan.
No.
Did it work out?
Well,
She didn't do it.
she didn't do
Good.
it.
All right, some common sense.
What I told her to do was put it in the bag of rice if she wanted to,
Yep.
and put it in the sun out on the deck.
Mm-hmm.
And a day later, it worked.
Mm-hmm. Well, so we've done a lot of this sort of research on what are you supposed to do with water damage, and I have pitched my own personal phone in water for demonstration a number of times. There's a video on my channel where I do that, and you can see surprisingly that the damage to caps is instant, not all over the board, just in a few spots. And the rice then is doesn't really do anything. I don't believe that rice does anything different than putting it on the counter or in the sun, something like that.
Yep.
Just leave it out to dry if you don't want to open it up. The thing that seems to make a difference is how quickly you disconnect the battery, because what happens to these caps on the main power rails, they'll turn into a wire, and then you've got a full short in the phone, and it will exhaust the entire battery voltage into that short. And that's when you get sort of the damage all up and down the board. That's what's going on with this one that's here for data recovery. You can see along the main power rail, this is ground side, line side, this is the main power rail. Other rails are not affected. So this would be a classic case of guy put his phone in rice and then put it in a charger, and every component along that line is now destroyed. They're not destroyed, but one of them's destroyed. we gotta figure out which one it is. So with my phone, I put it in rice and then took it out ultimately and figured out how to dry it out and open it up, take it apart, clean the board with isopropyl alcohol, and then I was really stunned that it turned back on. What? This thing had been in a toilet for like a day, and it turned back on, and that was really remarkable. And it would function almost completely normally. It would function in every way except for the fact that it would not charge.
Wow.
So it would be fine if you put a good battery in it. It would be fine. And it would be fine. You could make calls. You could see all of see everything that you had been doing. You could see all your texts. It was so alive.
So, was it because the battery itself was damaged then?
Well, that was my first thought. So I said, why don't I order a new battery? So I ordered a new battery from iFixit.com, and these guys have done a phenomenal job of doing this kind of things, take aparts and tear downs, and then putting what their findings. For everyone to kind of see the inside of their devices, and they sell parts, and so I did initially just do that. That was my first plan. So got the new battery, which comes with some amount of charge in it, and that made it turn on again, but it would not charge that battery. So then the very first job I did was a job like this to replace the charging port on the 4S. So, hey, iFixit.com, how do you do a charge port? So I tried 2 new batteries and 2 new charge ports, and it would not charge. So it was a board level problem, and that's kind of what led me down this entirely new career path of figuring out how to troubleshoot and solve iPhone motherboard problems.
About how long ago was that?
That was a few years ago, maybe 4 years ago.
Yeah. So let me get this straight.
Okay.
you have a you get a PhD in molecular biology. Is that what you said?
Yes.
And you work in that
Yep.
arena for a while.
Yep.
And then one day you decide, I'm going to repair iPhones now.
Yeah.
And I got to tell you, I'm experiencing a little bit of humiliation here because
I told you could fix this yourself. I told you I was going to have you do it. You can do it next time.
See, I'm intimidated by.
That's because you're an engineer, and engineers by nature are fastidious and notice things like, oh, if this screw is 1/10 of a millimeter longer than the other one, that's going to mess things up. Moms don't care about stuff like that. That's what this is. This is that, and so there's sort of, as a mom, this was just fun. Mom, you know what moms do all day? They clean the house.
They unscrew stuff. They
exactly.
They straighten.
They wipe butts.
Terrible dilemmas out.
Yeah, they run the same vacuum cleaner over the same carpet every single day. They, and I noticed. I remember having this moment where when I was in grad school, I was thinking about and trying to solve human disease problems. And now I had this moment where I spent maybe 15 minutes at Wegmans staring at the air freshener aisle. Now, do you think I should get the apple cinnamon or the white rain? Because I don't know, sometimes the apple cinnamon smells kind of burned, don't you think? Like my entire world had come to the point where I was taking the entire brain power that I used to use to try to solve problems that no one knew, to decide whether or not white rain was better than apple cinnamon. So then when the opportunity to stay at home, be a mom, and at night kind of try to figure out how to make broken things work again, that was just really fun. So it was a hobby.
But with your intelligence and education and background and ambition and all that stuff, why iPhones? Why not brain surgery? Why not neurosurgery? Why not?
Well, I kind of...
Or is that, those come next? You're going to do that when you get tired of the iPhone?
I feel like I kind of already did that. So what I learned as a research scientist is that you can be as creative and thoughtful as can be, where you can come up with, what if the reason that's like this is because this works like that? And it can be a really clever, creative idea. But if that doesn't happen to be the way it works, if biology says, good try, but no, then the amount of money and effort and time it takes to even ask that question is extraordinary. And then at the end of it, if the answer is, good try, but no, that's not how it works, it takes years to answer the question, an enormous amount of money, and then no one cares if the answer is, nope, good try. You can't get funding, you can't get grants, you can't get publications, you're under pressure, you can't keep a job, because you have to be lucky.
Yeah.
In order to do well in science, you're required to be lucky. Now these things are as equally to me as motivating, where that entire row of devices over there are people sending me, phones like this, where, let's see what this guy is. I haven't read this note, but, I'm requesting data recovery of photos and videos. I need it reassembled so I can fight Apple for coverage if you have any questions. So, here is this guy from Louisville, Kentucky, and he's sent his phone here, and the classic case is my baby's memories are trapped in this phone, and Apple can't get them out, and they're telling me the only thing I can do is just turn this phone in, and that's devastating to me. So as a mom, and all the other people that work here are also moms, it's incredibly fulfilling to be able to look at the board, like, hey, what just kind of figure this stuff out at the level of schematics. So what we primarily do is board repair, troubleshooting, and trying to solve problems in order to get that. The only path to data is to get the phone to work again. Mm-hmm. So because everything is encrypted on the flash memory chip, there is no way. You can read it, but it's just encrypted. So there's no path to data other than find out what's broken here and fix it, and then it'll turn on again. And that's amazing. So here's a guy that's over here in the done pile that this guy has 128 gigs of of stuff, and we just told him, hey, it's good news, it's recovered, but this phone was, absolutely stone dead. I don't know if it works with his screen or not, probably not. But, right now his stuff is backing up, and he's gonna get back 10,507 items of important data. So that you can do from your dining room and reach people all over the world. It's been really fun having a YouTube channel and talking to folks from everywhere, and it's a fun community.
Okay, so you've got quite a collection of sophisticated electronic equipment here that I recognize being.
You do?
Being
Awesome.
an engineer and all.
Great.
And
I bet chat can't wait to ask you some electrical engineering questions.
I'm seeing power supplies and
Yep.
High power microscopes, close to 10 microscopes it looks like roughly. And
Yep.
So and you're the owner and you financed all this.
Yes, I did.
Yourself, right? So
Yep.
you went from mom to financier and
Well, it was
business owner.
I went from mom who's fixing a phone that's in a toilet to lady who goes on Craigslist and says, "Hey, bro, I'll buy your cracked iPhone 4S," and learning and doing simple things like a screen change, and then sell on Craigslist. And then I went to local Craigslist. Can anyone change an iPad screen? Sure, to helping some dad from another town. He came to the dining room and I changed his daughter's iPad screen to a pink screen because you could do that at the time. And then I went from that to what happens if I buy a lot on eBay of devices that I could refurbish. And then that was really fun, so I did that for a while. And then I became more and more invested in the board level repair, which was a niche at the time. So I did buy a microscope, and I bought a relatively crappy hot air and soldering station. And then I started talking to people on the internet, folks from all over the world that, especially in other countries, they have more of a motivation to repair than we do here. So they have a huge knowledge base of these kinds of problems. And so I started being able to fix simple repairs like backlights and connector damage. And then I started offering that for sale on eBay. And I was doing this as a full-time mom in my dining room. And after a while, I started to kind of acquire some proficiency and become known for this. And then I became outspoken about the industry and doing things like this. Like, hey, look what Apple told these guys. So then I kind of developed a reputation within the industry. At the time, the industry did not have a sense of community. And that sort of developed over these years. So there became a worldwide community of people doing the same thing that started to share information. And then over time, I became relatively well known, largely because my story was funny and I was a woman, and nobody expected that. That's really the only reason that set me apart from everybody else doing the same kind of thing. And then I decided to start a school, because there's a lot in an industry that's really led by forums and talking online. There's a lot of what I call please bro solutions. My iPhone 5C headphone jack, please bro, what's the solution? Change headphone jack, yo. There's a lot of that, and a lot of that is misguided information. So, in one device it would have a signature failure. The backlight coil in the iPhone 3G had a location that was where water went when it hit the phone. So the backlight coil was what always was the problem. But in every other phone, they moved that. So now there's a ferrite filter that would clearly act like a fuse and protect the circuit. So that's going to be the common fault from iPhone 4 through everything else. Even today, you'll see people that will say, my iPhone has no backlight. It's the coil, bro. No, it's not. It's going to be anything but the coil on these 5 series phones. And if you try to change the coil on a phone that doesn't have a coil failure, and that coil is located near the CPU with underfill under everything, that really that makes a phone that could work again not work again. Mm-hmm. So that's why I started a course. And so I really just used revenue that I generated in the dining room to invest in course equipment, which initially we were doing at the Holiday Inn in Victor, and it was all in my garage other than that week. So then the course kind of became pretty popular, and I was a teacher by nature already, and that's kind of the story. So that's what we did. All right, I'm excited to hear what chat has to say. With an electrical engineer in the house, chat, what questions do you have? What questions do you have? All right, his daughter seems really bored. She is loving this. She's just chilling. She's look at her happy smile. See? All right. Okay. I guess she's reading chat. Like, oh, hi, chat. All right. Let's see. You can see the data without fixing it. What are you talking about? Who is your guest, by the way? This is a local guy who came in for an iPhone 5C headphone jack repair that we're gonna try to fix up. But we just found out that Mark here is an electrical engineer, and since we stare at schematics all the time as untrained people, it will be. I think it sounds pretty fun to say, "Hey, what do you think is going on?" In fact, let's do it. Well, I'm gonna have to stop talking so that I can put this together. So let's try. Let's go to the last thing that we were talking about. We were talking about iPhone 5S TriStar chip, our favorite chip. All right. So this chip appears to be a permission chip that receives these three power inputs from the power management chip. So there's this guy here, 3V0 SD-RAM, 1V8 SD-RAM, and then this other one, 3V0 accessory power. So that's the plug into the chip. And this is kind of it seems to be like a data management chip. So let's stare at this for a while. So a lot of these lines over here are all, we're going to put chat kind of down a little bit. So these lines over here, this is the charger voltage that goes into the chip. These, we're guessing, are accessory power lines out from this, kind of get routed out through there. These lines we know that they go to the dock connector itself, and we know that E75 is a chip that's in the lightning cable itself.
What did you call it? The what connector?
The dock connector,
okay.
the charge port, the same piece.
Yeah.
So like on yours, this piece that we're putting in, so charge port, and then this flex that we're ultimately going to plug it in there. And so these lines then, some of them, oops, let's go back to screen. They come back and plug into this chip. So this chip is sort of the negotiator chip that is going to negotiate communication through the USB port.
Yeah, and that's also obvious on the left side. It also talking UART, so that's all communications lines and whatnot in and out. I don't know what a SORI is and all that sort of stuff, but
neither do we. We just sit here and stare at things like this and guess.
Yeah.
So this is sort of a now. How do you pronounce that? How do you personally say this communication protocol? I get in trouble a lot because I say I2C instead of I2C as an integrated circuit.
Yeah.
Yeah.
But it says I2C right there.
Yeah.
I refuse to say I2C.
Yeah, I've always heard I2.
Yeah, that's right. All right, then this, for example, here's my question. This is the thing I want to look at next. So this guy's name is TriStar. So this chip is TriStar. TriStar, we'll say, is the negotiation chip for USB communication. And he's going to tap on the shoulder the charging chip and say it's okay to charge, or he's going to send out an accessory voltage if I need to power a fan or a dongle or something like that. So that's what I'm guessing he does. I am guessing that this line here is lightning cable. Somebody plugged something into me. So this is sort of, I detect that there's a connection when that line goes low.
Connection detected.
And then I think this line here is the output of the chip. TriStar to PMU, and then I guess OVP means over voltage protection, I don't know. Switch, enable, I don't know. But I do know that this line seems to be the signal that this chip generates in order to say it's okay to charge. Because this line goes to the charging chip. So I think that's the thumbs up for charging. And then this one though, this is TriStar, so this guy, to application processor, CPU. And I'm guessing that int means interrupt.
Or interface.
Interface? All right, that's a good idea, or interface. So one of the things this is the kind of stuff I do, scientific hypothesizing. So let's go with the idea that it means interrupt, and maybe that's not true.
I bet it does. The fact that it's INT only, that's all it's got over the far left.
Mm-hmm. Yes.
It's
Mm-hmm.
probably interrupt.
Okay. So in that case, what about this case? What if, would this be reasonable in any way? If I have a device that will charge when I first plug it in and wake it up from dead. So it's off, I plug it in to prompt it to boot via USB, and it will pull normal charging current according to the USB ambient. But if I then later unplug and replug in the charger, it does not continue to charge. Could that be a failure of everything's fine here? It can generate the, hey, I can charge signal, but there's something wrong with this line, likely internal to the chip, because this chip gets damaged by gas station chargers all the time. So if this interrupt, if it can't go tell the CPU, hey, excuse me, I want to tell you something,
Right.
pay attention to me. I mean, I'm just making this up. I have absolutely zero training in logic signals or any of this stuff. So this is just kind of, just applies common sense to a bunch of letters.
Yeah, it is how it works. It sends an interrupt signal.
Okay.
And if it can't get the interrupt, then it's
Ignored?
It never gets notified. It doesn't know to do it.
So I think it would generate the signal that says it's okay to charge, but then charging still wouldn't happen.
Right.
So I kind of like that theory as problem with this line would explain that phenomenon. But maybe it's not the only explanation, I don't know. All right, let's see what's going on in chat, and then I gotta go screw in these screws, otherwise I have to get Christy to do it because it's taking a long time. Let's see, if you replace TriStar and it still won't charge, it has to be PMIC. They're talking about something else, let's see. Chat has been ignored by Jessa for too long and is starting its own conversation. All right, ask him what we discussed on another stream about Q1403 on iPhone 6, why it gets hot when the short is somewhere else on VCC main. All right, that's a reasonable question from Rodrigo. And then we're going to wrap this up because you guys are like, this is not how we plan to spend the day.
Well, actually, this is
You're definitely like that. You're like,
actually,
okay,
this is very entertaining. We're going to break some more stuff just so we come in here and
chat.
fun,
Yes,
yeah.
we love to do fun streams, and we're always sort of off the cuff. So here, all right, we'll ask Rodrigos questions, and then I'll get these screws in here, and I'll be quiet. All right, so Rodrigo's question is, if you look at, and let's go to China. Let's take a trip to China, where these guys have made a tool called Zillion Times Work. It makes your work zillion times faster. So this is let me go take this over to screen. So ZXW tool is a dongle that you buy that gives access to these Chinese servers, and these guys have said, hey, we've put together a board view. So one of the common faults on iPhone 6, just like the one that we were looking at here in my data recovery queue that I was working on just a few minutes ago, this is the power management chip, and see how the VCC main power rail is corroded all down the line.
Mm-hmm.
So let's kind of, we'll flip this around so that it matches the board view. So that's the chip, and here's some VCC main caps. All right, so from here, we're gonna go to this board view where it is highlighted that net. So this is VCC main, those are those same caps. And so here's the power management chip. Power management chip seems to take the VCC main rail, which comes from, ultimately, the battery. So the battery, let's go down to the battery connector. The battery is here. So battery has a battery VCC, here it is. Battery VCC goes to a couple of different chips, vibrator, motor, speaker amp. And one of the things I've always wondered is, why are so many things powered off the battery, which would, I assume, have variable voltage? Like, why would they do that? Why not make the speaker amp chip, like everything else, be powered off of a PMIC power rail?
Well, if it doesn't need a regulator, if the system doesn't care, the battery voltage is dropping over time, as
Right.
you know. And if it doesn't care, if the particular circuit doesn't care what the voltage really is, like the vibrator, it probably
Right.
doesn't care. Then why put it through a regulator? You know,
Okay.
why put it through a regulator chip? It's just more stuff to go bad, and
Okay.
the regulator chip burns
Alright.
energy, and
Okay.
so
So it'd be more energy efficient to just
Yeah.
leave that out.
Yeah.
Okay,
So
makes
you
sense.
only regulate it if
If it
it's something
requires it.
critical that
All right.
like the oscillator chips are
Yep.
very sensitive to the voltage, and that sort of thing.
All right, so then from there, the battery goes to a couple of dudes, and then ultimately it goes here to this chip called Q1403, which is it seems to be maybe a protection MOSFET. So this is, let's look at Q1403 on the schematic. So this is battery VCC, everything else about it is VCC main. So this is sort of the connection, the main circuit breaker, I think, of those two things. Let's look at it on the schematic, and then we'll get to Rodrigos' question about this. So this guy's name is Q1403, so let's look up Q1403. Here's Q1403. So Q1403 is connecting battery VCC and VCC main, and then it seems that then this gate here goes into this charging chip, and it's called this. I don't really know what this charging activated diode, I guess. Does that mean that when it's charging, it's going to break the connection between battery and VCC main so that the 5 volts from the charger, so we've got 5 volts from the charger coming in here, goes through the chip and ends up being delivered into that line, and that's how the battery charges?
Well, you went kind of fast. The gate connection is the control connection.
Okay.
It's not a power connection. It's strictly a control connection. So the U1401 is controlling the MOSFET over here through that control line.
So why would he ever turn this off? It seems like he never turns it off.
Well,
would it be turned off during charging?
Is it turning it off, or is it regulating? A MOSFET can be an on-off device, but it can also be like a valve.
Okay.
You know, so it's controlling it. That may be the thing that's actually regulating the voltage.
Okay.
I don't really know, unless I really study that schematic. But do you think that's a protection device, or is it a regulator device? It can be both, actually. It could be.
I think this really is just a connection. Like in my experience, battery VCC and VCC main are pretty much always connected. They're always the same. So even if the device is off, VCC main is filled with blood, as is battery. You know, so and that's why, like in water damage, you will have a VCC main voltage present all the time.
Yeah, but is there another regulator to your knowledge somewhere else?
On VCC main, no. This is the only MOSFET in the phone that's not part of a chip.
Okay, so and there's no one of these is battery and one of these is
main power
downstream of the MOSFET, and there's no other regulation going on to your knowledge.
To my knowledge, right?
Okay, so it's probably a regulator / protection chip.
Okay.
It's as a battery is draining. You know, what is the battery voltage typically?
It's between 3.8 to 4.2, depending on how charged it is.
And what's your VCC main?
It's always battery voltage. It varies as well.
Oh, okay. So it's not controlling it to exactly 3, no matter what the battery voltage is.
Right. So VCC main goes on to the power management chip. So the power management chip itself is, let's actually look at it on the schematic. So the power management chip is sort of the heart of the phone. So this VCC main then plugs into, is it U8100 in the iPhone 6? Let's just find it. Let's see, what is the exact number on it? The power management chip, U1202. U1202, yes, U1202. So U1202 is the iPhone 6 power management chip. So here it is, and you can see just from far away, all of this is that VCC main power rail. So it's coming from battery through that MOSFET to VCC main. It's plugging in to all of these buck converter and LDO sections of this chip. And then the output of this chip is a whole bunch of individual power rails.
And are they all the same voltage, or
no? They're all
doing some switching and DC to DC conversion and all that sort of stuff, right?
That seems to be the majority of what it does. It makes all these lines.
All right. So then that MOSFET at the far right is probably just protection. It's not doing any regulation or voltage control or anything like that.
Okay. So then Robert's question, or Rodrigo's question was, and this is sort of
why does something get hot when the short?
Why does it get hot when the short is really somewhere
So now show me
else?
which part is actually getting hot.
Okay, so the guy that gets hot, if you have a short anywhere, let's say this cap is short, 1263, and it's on VCC main. So Q1403. Here's Q1403. So this is the guy. This guy gets hot whenever there's a short anywhere on VCC main.
Okay. So here's why.
All right, let's hear it. I'm ready. All right, guys, we're gonna learn. Are you excited? All right, let's see.
So what's happening is the if there's a short downstream, that MOSFET is apparently trying to do some protection.
Okay.
So it's probably dropping the voltage on the voltage on the other side is a lot lower than the battery voltage, probably, or something significantly lower. Now it's still letting some current through, but it's dissipating a lot of energy. It's like it's like grabbing a hose, a garden hose, and doing this to it. You can hear the water trying to get through there. The water's bubbling, and it's actually boiling is what's happening. Mm-hmm. And so that MOSFET has become the bottleneck.
Okay.
And it probably has a volt or two across it, I'm thinking, and I don't know what kind of current is being drawn, but in trying to protect the downstream equipment, it's lowering the voltage. It's become this huge bottleneck. It's trying to turn off, and it's not turning off completely apparently, mm-hmm. and so it's just heating up. It's just dissipating a lot of energy. Mm-hmm. Does that make sense?
Yeah, I mean, my theory had been because he doesn't have a path to ground and everybody else does.
No, he wouldn't get hot if that was the case. It's because he is.
It's like he's getting hot. They're all going to get hot, but he can't do anything with the heat because he doesn't have a foot on ground. Like if a cap has become a wire, he still has 1 foot on ground. So even though he gets hot, he's sort of that heat is going into the ground plane.
Well, that's true. That's true. If he's got nowhere to dissipate that
right.
heat.
So, but this guy's the only guy that doesn't have a foot on ground, so he's going to get hot because he's got so many connections to the shorted line.
Now all power goes through him, right?
Yes.
All of it.
Right.
So he's hooked up to the main source of power, the
right.
battery,
mm-hmm.
and he's more or less blocking. It's like he's
right.
he's pushing. He's holding Niagara Falls back.
Right.
Is what he's doing.
Right.
But he's not doing it completely.
Right.
And so some energy is getting through, and power is voltage across the device times the current that's through it. So if he's got any current and he's dropping a volt or two, mm-hmm. he's dissipating a lot of power.
Mm-hmm. So if you take that guy and if you inject the VCC main voltage somewhere else, like up at the top of the phone, then he doesn't get hot as quickly, and so you'll likely be able to see who's the
Yeah, you're bypassing him.
Right. But there's a lot of times where, I mean, we do this sort of freeze spray technique, which is probably a terrible idea, where we use this stuff. Make it ice board, apply a voltage to what we know is a shorted line, and look to see what melts first.
Yep. So many years ago, I used to repair TVs.
Yep.
Off and on, and if we had a power supply problem, it had a protection circuit like that MOSFET. The
yep.
first thing we would do was short out the MOSFET.
Yeah.
But bypass it, in other words.
Right. And a lot of times I'll just take it off so that I can see where the short is.
Yeah. So we would bypass the protection circuit, until something fried.
Right.
Then we knew where the problem was, and we'd fix it.
Right. Yeah. See, that's what we do. Practical repair. I love it. That's what we call it our school, practical board repair school, where we do all kinds of.
So I don't know if I've explained it, but that's what's going on very well. I don't know if I've explained it very well. But
yeah, I like that.
That's what's
going
on. It's like that poor MOSFET is trying to hold back Niagara Falls, and he's expending a tremendous amount of energy trying to shut off the current that's trying to go through a short circuit downstream of him.
Sounds good. Let's see what other questions these guys have. It's like spraying a jet of water into a big sponge. It still flows by without the air and pressure. The body diode on Q1403 is where all the current goes from the battery to VCC main. I have a shirt for that. Buffering. I can't help you with buffering. Let's see. The MOSFET is a gatekeeper. The traces have a far lower resistance, so heat is dispersed by the MOSFET. Let's see. Internal resistance makes it hot. I bet we will see him on as a guest again. That's pretty funny.
Maybe.
Well, we'll see. Yes. In with a spinner. That's really funny. It sounds like they're We learned a lot from having we had a guy that is a circuit designer. So he is working for a startup company, and we kind of met him at Flaherty's up the street, and then he came over here and we were talking shop for a long time. But he helped me understand something that I struggled with for a long time, this chestnut problem. This was something I had stared at for a long time and had no idea. What is it, something like U1501? Yes, chestnut. So I didn't know this guy for a long time. So this what I could get from this initially was, all right, this seems like a boosting power chip, a boost converter, DC-DC boost converter. VCC main, I see a coil, I see switching at a coil, I see some data regulation of this guy, so an enable, and then I see output, and these outputs are all higher than the incoming voltage. The incoming voltage is VCC main, which is battery voltage. So so what this guy is doing, as far as I can tell, is taking VCC main, switching a coil, and generating an output boosted voltage.
Yeah, that's exactly what he's doing.
But I didn't know about this guy. So this guy didn't make any sense to me for a long
which
time.
part?
This C1554.
Okay.
So that I thought, I don't know, feedback, I didn't know. And this,
Well, what's the question? What's its purpose?
What is that guy doing? Why is he there? What's up with a cap that just has one foot on this pin and one foot on the other pin? Every other cap, almost all the caps in iPhones are these filtering caps that just seem to be cleaning up noise from lines.
All right, this is an educated guess.
Okay.
So you have DC coming in,
Yep.
and what you're going to do is there's an oscillator in that chip somewhere,
Okay.
and so it's basically converting the DC to AC,
Yep.
and at a high frequency, and then it's using either some kind of switching devices or tiny little transformer internal to it to get these auxiliary voltages that are higher.
Mm-hmm.
And my guess is that that's a filter capacitor. Is it a large capacitor? I mean, relatively
Yes,
large.
it's large.
compared to this?
Mhm.
So it's the filter capacitor on the main the thing that converts it to AC and then rectifies it at the higher voltage. So it's like a power filter capacitor
Mm-hmm. Well,
on
what
the higher voltage DC.
Chris's guess was, which made a lot of sense to me, he said that is likely sort of the same thing you're saying, integral to the function of the chip. But he said in order to actually put that inside the chip would have an expense in real estate of the silicon die, and so therefore it makes sense to leave something like that outside the chip and that you just kind of connect to it.
Yeah, he's right. To make a
Something like that.
capacitor on an integrated circuit is doable, but they consume capacitors are basically parallel plates, and they consume a lot of. If a big capacitor consumes a lot of area, needs a lot of area.
Right.
So
to
that's
keep
why-
the footprint of the chip small, you just stick that cap outside.
Yeah.
And so then I was like, oh, that makes sense, because if that guy is gone, then that chip doesn't work at all. So you'll lose all of your output voltage if he's gone.
So any capacitors that they actually integrate onto chips are generally very low, very small, electrically small, picofarad, nanofarad type stuff. But does that have a value on it?
10 microfarad, I think.
Yes, it is 10 micro. So 10 microfarad is huge.
Yes.
And
yes.
it would take an enormous. It'd be bigger than all the rest of the chip.
Yeah.
Itself.
Okay.
To make a capacitor that large on a chip.
All right. Well, that makes sense then. I like it. All right. Let me try to get this back together. So let's see.
So one of them asks, is that an AC filtering cap?
Yeah.
I think that's what it is. It's large because it's filtering the DC that's been converted to a higher voltage.
Mm-hmm.
I would think that's why it's large.
Yeah. So Chris Long is a guy that is in Bowling Green, Kentucky, and he does pretty much a lot of the exact same stuff as we do all day, every day. And he's very thoughtful and has good questions, and he's always willing to go down the rabbit hole and try to solve difficult problems. So we're gonna try to get this back together. So Chris Long, what kind of burning questions do you have so that I can get this simple, I promised 15-minute charge port job done? And I'm starting to think I might have lied about that. So let's see what you guys have to say. All right. Do you know it's not working when it's too hot and it burns your lips when you test the heat on the board? Am I the only one who tests the heat that way? No, that is the pro method. That's the practical short detection. You don't have to stress the board out with any kind of alcohol evaporating or something like that. Now, what's the true pro way to find a short? I mean, these if we try to measure like milliohm resistance, we don't get anything. There's too much noise.
Right.
So the lips method is a go-to method?
Well,
Yeah,
okay,
let's
so
see what gets hot. Short circuits generate heat, so I do a lot of this with boards that are hooked up to
Yeah.
DC power. Oh, it's right there.
well, nowadays I would think so we always use an infrared camera.
Well,
but-
we got an infrared camera right here, the old FLIR one.
Yeah.
But it's not the
It-
resolution. It'll
yeah,
just kind of
resolution's
tell
not
you
good
like
enough.
what side. it goes.
So what about something through the microscope? Well,
Like an infrared microscope?
No, you need special optics, wouldn't you? We had a very high power, high resolution infrared camera to look for stuff like that.
Like what kind of resolution? I mean, these boards are super tiny.
Oh yeah, yeah. I couldn't tell you off the top of my head.
Something like that would be able to resolve.
Yeah.
So $50,000 camera?
Probably was, yes.
I don't know about that because lips are free, and they do a pretty good job, I think.
So tell me what size you would be trying to detect something hot on there. Point to something that.
That would get hot.
How small would something be that you're trying to pinpoint? That's the thing that's
the
getting
missing cap here is a hot spot, signature failure.
Okay, now show me where that is. So that's that tiny. Oh my
So
God.
it's now missing, but right there.
Yeah. So you need something with high resolution. I see why you're using lips and stuff. Yeah.
You can be like this. You're like, yeah, it's right there. Yeah. Oh yeah, right there.
Now you can get thermocouples that are that small, and a little probe.
Really?
you know,
That tiny? Yeah.
Little probe, a little thermocouple on the end of a probe.
Now, what's the value of a board that you might typically be working on back in the day?
Oh, well, we're using control boards. Maybe, they're the smallest ones we worked with were probably 6 inches by 8 inches, and they were basically a specialized computer board that had some fairly, 24 volt switching devices on the output. So there's probably about a $5,000 board.
Yeah. So these are phones so we have to have kind of a Walmart approach to this a lot.
Yeah.
Where the Apple store has said, yeah, there's no money in that, we're not doing that at all.
Yeah.
And so there's one thing to kind of just change a fairly straightforward part swap problem, but when it is diagnose and troubleshoot board level problems where you're having to source we put in these BGA chips that we get from China, that's tough because you have to be quick about it.
Yeah.
And you have to be able to kind of find the answer. A lot of them, however, there's just so many of them that I'm always looking for signature failures, and every one of them has some signature failure, and once you figure that out, then you can really kind of go.
Yeah, I remember years ago when I was doing TV repair during college and all that sort of stuff. You had to do a lot of this repair based on knowledge. You couldn't really troubleshoot. You had to.
Right.
You had to know that 95% of this board that comes in, it's always this diode over here. That's
Right.
low,
Exactly. Yes. That
or
knowledge
or
base.
eat you alive.
Yeah. Oh, hey! I found your other screw. It was
a loose screw.
Yeah. Look at that. Great. We found it. Right there. That's really funny. That was totally hanging out up there. I wonder how.
How the heck did it get there?
I don't know. Just
Came
must
loose?
have come loose or something like that.
So it just slid into that one spot.
Yeah. Kind of weird. All right, let me get this. This dude needs to
So
get back
do you
in
need
there.
to like, make a rattle noise if it like came loose and it was like in that one spot?
Not if the that's exactly where like the screen bracket plugs in, so I think it probably just kind of inadvertently got secured there.
Huh.
It's just kind of a weird thing, which is probably why no one noticed until now. All right. Sunday, internet pervs are checking you out. Just FYI, we might be live streaming.
You can't even see me.
Apparently you can, because holy shit, is that Honey G in the house? Says Fix It Daz.
What is Honey G?
I'm pretty
Like, well,
sure that Honey G is what they call you. I
Can I
mean,
get a shirt? Is this Honey G?
yeah, I think you should. Well, Honey G it is. I'm pretty sure that's you. I mean, call me crazy. All right, we're coming down the line here. Alrighty. I find all my loose screws stuck to the magnetic screwdriver on the next job usually. So what is going on? Who's the mister? For anybody that hasn't been hearing us ramble for the last 15 minutes, this is Mark, who is come here, just walked in the door today, just met him, and he brought an iPhone 5C over to the Apple store at the Eastview Mall because it had a pretty straightforward, needed a new headphone jack dock connector, and Apple store said, we don't do that, but kudos to the Victor Apple store. They did tell him, so we'll sell you a new phone if you want, but they said, hey, you know what, you can also just go down to iPad Rehab or a similar place and they will probably be able to swap that out for you. We just don't do it here at the Apple store. So good job on the Victor Apple store for doing that, and that's what brought Mark over here, who turns out happens to be an electrical engineer. So we decided to commandeer him. We throw up a live stream and we are going to ask all sorts of fun schematic questions while we screw in the last couple of screws. So this is your chance, chat. This is your chance to ask any of your burning electrical engineering questions. I know some of you are electrical engineers, but we always like to see what it's like. I think it'd be really cool to see what an iPhone schematic looks like if that's the field that you work in. I think that would be pretty cool. All right. Apple says GTFO. We don't do that.
Someone doesn't like Apple.
Yes. The stream is buffering. I can't help you with that. I can't help you with the internet here at the shop. You can tell, though, that whenever school lets out, that is when stream stuff takes a hit.
Really?
Yeah, it's really interesting. It's like as soon as the school lets out, everybody gets on their phone. Everybody's, getting home and clicking on Wi-Fi. So what's up with spinners? How many people do you know have a spinner?
Oh gosh, I don't even know.
Like all of them or none of them? Like, is it a big thing?
I've been seeing them in Eastview.
Yeah, I mean they're just like everywhere. It's like,
I've been hearing them on the internet and.
Yeah. I mean, it's just taken over the whole world. All right, let's see whether or not this
I heard
actually
like
solves the problem.
something that's like called like the fidget cube. Which
Yes, a fidget
I don't
cube.
know how that works.
I think it's just kind of press on these things and flip it around. I think. All right.
So you know a lot of the people that are on the that are online, right? Is it?
Let's see.
through
People
the
that I've
internet?
met in person, it would be. Let's see. Greg M, I remember last night made a good suggestion when I was troubleshooting an iPad mini battery problem. Pretty sure it was the same Greg M. So I will then remember Greg M was a guy that showed up and made a good comment. A lot of these people I don't. Amy Marie is somebody that I made a mod on the channel because I noticed her on multiple other microsoldering channels, and I thought that she was also making good comments. Some of them may be people that have come to the course that I don't recognize their usernames. I don't know who. Chris Long I've met in person because he was active for the right to repair, so we went down to Albany, and he's in Kentucky, so I went to Nashville to talk to those legislators to just say, I want the right to be able to buy that part. And I think that you don't have to sell it to me, and you're not, but if you don't, it monopolizes repair, so that nobody can repair. So they could have chosen today, and there's nothing that prevented them from telling you, we're not going to sell anybody this part, and we're not going to repair it yourself. Your only option is paying $300 for a new phone. They have the right to say that to you. And that's really a tough issue for folks, because in the automotive industry there was a huge right to repair stuff, where now the letter of the law is that you have to allow third-party or independent repair shops to have the same access to parts and information that you give to your in-house repair people. So the guy that's actually turning the screws and doing this job in Texas, he's allowed to buy that part, so we want to be allowed to purchase it.
That seems very reasonable.
At the same price. I think it seems reasonable, but it is very. It's a business. They're there to make money. You don't get to tell businesses what to do. It's tough. So we went down to Albany, we went to Nashville, we went to Nebraska, and I met Chris Long in person there. All right, let's before we put the screen all the way in, let's see if this actually solved the problem or not. All right, let's find out. Your video will play after this ad. Great.
I use like the music app on the phone.
You use the what?
The music app.
All right, well, let's just listen to this Sprint ad. Ooh. All right, let's see. All right, let's hit play. I hear it. And it says headphones.
Nice.
It's your favorite song. It's gonna be great. All right, let's go ahead and.
Have you ever heard of R5?
No, but I'm gonna totally put it on Spotify right now. I always need new Spotify suggestions. R5.
Yeah, they're a band.
R-5. All right. Which one's the good one?
Air, right? Pro.
Shady Boy.
Oh, it's just R5. There's no dash.
Oh, there's no dash. Oh. R5. These guys?
Yep.
All right, we'll check them out. We'll play them. We'll play them in the
I
shop.
when to see him in Daring Lake.
Oh, cool.
Meet and greet.
Alrighty. All right, let's just make sure that it charges so that we can test other functions through the dock. All right, so that's pulling normal charging currents. We'll give that a yes. And we heard the loudspeaker. And we'll go ahead and get the screen back on. And be kind of good to go. All right, so that was from before. Alrighty. Let's get back to this. All right. Just be careful with copyright infringement. I did not play any songs, but yeah, that always stinks when you do something like that and then they're like, YouTube is like, your video gets a copyright strike because we know that R5 is not okay with you playing a stanza of their music. All right. That already said. iPhone 6s stuck on Apple logo after 2 days of replacing the TriStar chip. The phone draws amps until it boots, and then after that, the amp draw is 0. Help, please. See, there you go. See that same thing where it charges normally. The guy has replaced that chip that we were talking about, and then after it boots, and then it stops charging. So it can only charge while off. Sounds like a current sensing kind of thing. We've put a lot of time into problems like that. Your first thing to do on that one is to just rule out parts and software. And I think parts and software are going to have a lot of this. We did a big stream on those kinds of problems last night, which was all about battery data lines. So gas gauge and temperature, things like that. All right. Yeah, it's interesting. Chris Long came up with the idea on some of these 5C charging issues to just jump across that MOSFET when you would get a phone that would kind of start to misregulate that open and close. So then he just said, screw the regulation. All right, non-magnetic compass screw going back in. We have to place that by hand.
So I noticed that this particular screw has some blue goop on it.
No, a lot of them do. It's just Loctite, I think.
Okay, so it's not the only one that does, is it?
Right.
Okay.
Yeah, that's, and you can see inside the screw holes in most boards. If you look down in the screw hole, this one's been through ultrasonic, so maybe not. But if you look in the screw bracket, yep, it's been through ultrasonic. A lot of times these things look like trash cans. One of the most detailed things that we do, see how tiny that screw bracket is?
Yep.
If you do mix up these screws doing a DIY screen change, and you put the wrong screw, especially in this hole, then it will tear traces in the board under that. So that's how tiny that is. But with this microscope, you can make it, you can crank it up to 90x and make it reasonably big. So we will desolder that bracket and then scrape the board away to expose the traces. And then we will dissect a vibrator motor like this. So the coil inside a vibrator motor, we'll look at that. Where is it? Ah, fail. So that wire that's in the coil of the vibrator motor, we can pull out strands of that and use that to make micro jumpers to repair the torn traces. So that is one of the things that they're never going to do at the Apple Store.
All right, so the part you just showed me, that's a coil. That's what makes that's part of the vibrator device,
Yes.
right?
Mm-hmm. So we're just using it as a source of super tiny wire.
And that looks like it's like almost like human hair size.
It is human hair size. In fact, Mark Schaefer, who does more long screw repair than anybody in the world, one time was wondering why his tinned vibrator wire he couldn't solder it down. It just wouldn't stick.
Oh no.
Again and again, it wouldn't stick. And so then he realized he had been trying to solder one of his own gray hairs that had just fallen down. And it kept burning up. I was like, why is this wire just burning up? Yeah, if you put a human hair next to it, you can't tell the difference.
Now that's enameled, right?
It is enameled.
And
yes.
so how do you not have to take the enamel off?
You just kind of burn through it,
yeah.
And it will be okay.
And how do you solder something that small?
You use the tiniest soldering iron that we have, which is the 0.1 millimeter micro pencil. And
Okay.
so under the microscope, it's pretty big.
And do you use that to solder surface mount chips and that sort of stuff as well?
We could. In general, I use this just for trace repair. I could use it to do a joint on one of these tiny little connectors.
What would you use typically then?
This doesn't have enough thermal mass to really heat up ground in order to do a lot of stuff. So I use these. These are the go-to tool, mini hot tweezers.
Okay.
Whoa.
So the mini hot tweezers are great for any of these connectors or picking off any of these tiny, like this dude.
What does it do? Heat when you close it, or?
No, it's hot all the time,
Okay.
like 2 soldering irons.
All right.
And then I can open and close it.
Oh, okay.
Use
So you put that on the ends of the surface mount
so
chip.
I can just kind of sizzle that up. Love, love, love these guys. And then we use the JBC hot air station, which I absolutely love for most of our BGA work and things like that.
And is that for removing stuff or soldering or both? Or do you
Both. Yep. So I would take a chip off.
And you use paste if you're replacing
No
a small
paste.
chip?
I would do so like this job here. Let's see if we have.
Are you going to charge me for all this instruction today?
Are you going to charge me for answering my questions?
No.
Great. All right. So we'll do this. Sorry for the workplace
Oh,
injury
that's
there.
sharp.
Yeah, those things need to stop leaping themselves off my table. All right, so we'll do in these 2 bottom screws. So the home button is the only thing we need to check because it has to actually make connection, which it looks like it is. Great. All right, so we will put in these two pentalobes, and then I'll show you us taking off a chip real quick, just because that's kind of fun. Now, what kind of soldering equipment have you ever kind of fallen in love with? Paste stuff?
So I didn't personally do any small soldering.
Yep.
We always hired that out to local board shops. We didn't build in-house
Check it
boards
out
or
and
anything like
play with it
that.
and see if that works.
But we did a lot of we would design the functional specification for the board, you know,
Yep.
custom computer board or something like that, and then take it to a local board house in the Rochester area that would design the board and fabricate it. We would do some occasional repairs, but the soldering was all done. The small stuff was all done at places that were better equipped than us. We didn't do enough of it
Works.
to
Awesome.
stay good.
Yeah. Well, we do, you know, for example, this chip is a signature failure on the iPhone 6 Plus. I don't know, like, how common is it in a spun board to have just traces be weak? Is that a thing? You know, like this is the iPhone 6 Plus universally will get a problem that we've called touch disease, where it will have what we've now, the whole community, these guys and everybody else in the world, have drilled down to realize that it is a specific defect, that the connection between the pad, the M1 pad, and its trace is weak.
And what happens? Does it delaminate from the board,
Eventually, the way we kind of figured that out over time would be this job. So initially we knew, like any touch job, you kind of figure out, I don't have a problem here or here, I don't have a short to ground, the connector's fine, and you kind of trace it back to the chip. So this is the touch data communication chip. So then the job would be to take it off and replace it. That would be sort of your first, hey, let's see if that fixes it. So let's do that. So this is what I use to do micro BGA.
I've got a question. So
Yep.
Is there like a way to keep the jag safe from like any like dirt or debris?
That is a great question, and I don't know the answer to it. I think certain cases maybe have, like an OtterBox or something, probably have a plug,
Or maybe like
plug
keep
for that.
it like in a bag to like for like when you're charging it.
Yeah, you know what? Here's what's really going to happen with that. You're going to go on, that's going to be fine for a long time, and then when it's not fine, your dad's totally going to change that port.
No, I don't think so. I couldn't have, if I did it myself, I wouldn't have all this fun. See?
That's true.
That's a good question, but
This is the
I
most
don't
fun I've had since I retired.
Wow! All right, all right. So let's take this chip off. Well, we're big fans of having fun, and there's other folks that are out there. We're always big fans of talking to people, and everybody's got something interesting that you can learn. You can maybe watch it a little bit more clear up there, I don't know, rather than right here. So I'm putting heat on this, and
Those
Can
parts
I
are like
heat up
very
this shit?
tiny.
yeah.
I bet like it takes like a machine to make that, right?
Oh yeah. Alright, so I just lifted that chip off, and then I would need to clean up the pads. And what we noticed was that changing the chip would fix it. It would always fix it. But then, compared to any other repair that we do, we have very, very low warranty issues in general. So now I'm just going
I think
to,
it's like steaming.
yeah, it's super hot. So now we're gonna, and I typically I have a fume extractor under there that is super loud.
So
we'll
if you were
just
to
get
touch
that.
that with your fingers, would it burn you?
Oh, it would totally burn you. Yes,
Oh,
it would.
Now, are you removing the solder?
Yeah, so I'm just
And
sort of
how are you
mopping
doing
this
it?
up.
What's absorbing it?
The iron itself.
Okay.
So there's solder likes to go where the heat is, so there's flux on there. And when doing that, if you later then looked up on the let's kind of make that big.
Also, I was asking about the iPad Rehab.
Yeah, if you make it big and kind of look at the pads, and we'll just clean that off with alcohol. And this is, this kind of seems very kitchen table. I have a friend who's an electrical engineer, and he's like, "You do BGA on the kitchen table? What?" Because you kind of grow up with a land of profiles and everything being important. This is practical BGA. But this is the people are constantly critical of, Jessa, you've got all this equipment, it's just, this is just, how can we do this cheap? This is cheap, And, but guys that are in Moldova and guys that are in Russia, they are doing this stuff with really, really inexpensive Radio Shack kind of equipment. So here's all the pads, and you can kind of go to electrical engineering school and learn about like never mix lead-free and leaded solder and blah blah blah, and voids and balls and cracks and stuff. So practical people say, that's probably not that big of a deal at this pitch, and so we just make them all roughly. I make them look like this, rather than braid them and make them flat or try to do anything else with them. And then I use pre-balled chips from China. So I would have a matching chip that would come with balls on it.
So it's got solder balls on the bottom.
Yes. So
Okay.
this has lead-free solder balls on it.
Now you have to place that by hand, though, don't you? There's
do.
no physical registration.
Nope.
That's gonna.
I mean, this is
align that
super
for you?
tiny, and if we were doing like a GPU chip, for example, that pad that you're seeing that's bad, you guys tell me, hey chat, do I need to be concerned, yes or no? Look real close. Do I need to be concerned, yes or no, about this missing pad? Where does it go? How would I know? What's the deal with that? So let's hear it.
So what's happened? What am I seeing there?
This is a missing pad.
Ooh.
So what I'm asking chat to realize is that this pad was a NC pad or a not connected pad. And
it was, or you want to know if it is?
According to me reading the board, that's an NC pad. Because if it wasn't, and this is just a donor board so we can mess around with it, if it wasn't, then it would leave behind a trace. There. That pad. See the trace?
Where are we looking
The
here?
copper trace. So
Oh
now
yeah,
there's
yeah,
two.
yeah, yeah.
Yeah,
The one down to the
Yeah,
right of it.
so
Yeah.
this one here.
Right.
That is a problem
Yeah,
because
so-
it's missing a trace.
You answered my question. What would it look like if there was
Right,
a connection? If
exactly.
there was supposed to be a connection.
Yes. So you have three choices. One is it was an NC pad. Two is that it was connected from the bottom. Or three, it was connected from the side. So see this one that you can read the board there? There's a trace there.
Yeah.
And so if this pad was missing, it would be connected from here. And so a lot of people mistake that as, well, I can't see the trace, I should dig for it.
Oh boy.
And so that's good. ZXW says NC. That's right.
No,
So
sorry.
they're saying they looked it up in ZXW and are confirming that that is a not connect pad. And those are the ones that are going to come off because they're not really attached to anything. So we just kind of gloss over it, and it doesn't really matter. It's not a big deal. But what we did notice with this particular chip is that this pad here, that the M1 pad which is important, and you can see the little trace.
Yep.
This guy would just come off. And after time with experience in doing this job 1,000 times, you kind of learn how to pull it off, when to pull it off, how to tin the pads, and you really don't pull pads like ever. So important pads. So we noticed, hey, I pulled the M1 pad. So did I. And then here comes another one, and it's coming back for warranty. And then I take the chip off, and the M1 pad's gone. And so over time, we just realized that no pad ever comes off except for the M1 pad, this pad.
Now, can I assume that's just a normal, what I'm used to, a copper foil pad that's
Yes.
adhered to the board and
Yep.
connected to the trace? And
Yep, so we use these for training a lot. These are bare boards that are, for all intents and purposes, the boards. That's just unpopulated. Yeah, we got a lot of stuff.
So is that from an iPad?
This is from an iPhone 6.
Ooh.
So that's what an iPhone 6 board looks like.
So you're gonna put a new chip down, say on any of these,
Yes.
and it's pre-soldered,
Yes.
and you're gonna reflow it with the air device you showed me.
Yeah. So we'll do one real quick, and then we'll.
And the chip can take that, huh?
Yeah. I mean, the way I teach about it, which is, again, just all practical information from doing experiments and kind of being more of a scientist than an engineer. So that's what I do. I say, what happens if I do X, Y, or Z? I'll do an experiment, and then if the answer is, and so I give it to the customer and I warranty it, and then I never see it back, then I conclude, so for a phone, a device that needs to last, how long does it really need to last? It's not a space shuttle. This device is going to age out. How many people are still using the iPhone 4? There's like 6 people left. And so it has to survive for a length of time that is the sort of useful life of the device. So we'll take this chip off, which is the other touch IC. So with this whole touch disease problem, which we kind of popularized quite a bit, it was really obvious when you look at it at this level. If I were to tell you as a reasonable consumer, hey, you know what, I change these chips all the time, I've fixed 10,000 devices, and I have a pretty good reputation and a strong warranty. And I'm telling you that this pad always pulls up. And so is that same experience of Chris Long, for example, who does the same thing. And a dozen or 100 other microsolderers. They all have the same experience. So after a while, you'd then have to think, why is that? And if you put a jumper here to just tag into where this thing goes, and you replace it with a piece of wire and you put a new chip on top of it, it will never come back. And so it can be permanently repaired with a micro jumper and a new chip. So that's what we do all day, every day, and have been for about a year. But is this a manufacturing defect or not? And does Apple have any responsibility for this problem? So as a consumer, what do you think about that? Yeah, it's right there. I'm not sure if somebody's in there. Is somebody in there? You just go knock right there. So I think that for us, it's crystal clear. No other pad. All these chips go bad. We replace chips constantly, but nothing else has such a signature failure like that M1 pad on the touch phone. And it has become a rampant epidemic with the iPhone 6 Plus, so much so that I think that every iPhone 6 Plus will ultimately get a failure of touch. And we have watched what has been the response by the manufacturer to that problem. And they initially were just in total denial. And geniuses working at an Apple store would say, guys comes in for his 6 Plus, and I have to sell him an out-of-warranty replacement for the touch screen, and the one I open up out of the box has the same gray flickering lines right there on the spot, because they are also refurbished. And it was a huge problem that even to this day, it took them months of flat-out denial or just not saying anything, banning me and people like me that would be very vocal about stuff from the spread of information on their forums. And ultimately, they came up in response to a class action suit with this repair program. For $150, they will repair their own design flaw.
Did you ever find out what the design flaw? It's almost like sounds to me like it's a flaw in the tooling that makes the board.
I think so, because there is a
damage.
Yes, there's a similar, and I don't really know how the boards are created. How do you turn a bunch of wires and whatever this other stuff is? So there's another similar flaw at another chip on the 6 Plus. So I just think a couple of inkjets got clogged somewhere along the way, or who knows. But it's pretty clear that these boards have a problem, and that you're not going to get the life expectancy out of them that you thought you would.
Yeah. What was the nature of the class action lawsuit? Who brought it, and under what grounds?
I think it was, even now, the policy statement on this from Apple is, this is user damage, this is end user damage from bend or drop or something like that.
Really?
And this happens in OtterBox kept things. And the reason they say that is because initially, the first people that would experience this flaw did drop or bend their phones, because it's like a fragile little leaf on a stem. So a drop or bend is what's going to bring that to clinical attention. So then it kind of became associated with drop or bend. And then it wasn't until the phone had to age enough that just normal flexion. So this is the first iPhone that had that kind of big chassis. And this is also the first time where, every other iPhone board has these EMI shields, which I've taken off of this one, all over the board. So they have shields that cover, kind of like this, metal shields.
Mm-hmm.
And the iPhone 6 Plus was the first one that had a sticker shield. So it's lost some of that rigidity that it had, and I'm guessing that they probably did that because of this near-field communications chip that probably has a rule that says you can't have a nearby ground plane or something like that. That's totally a guess that I just made up, but I don't. There must be some reason that they did away with it.
Yeah, it's a reasonable guess.
So it doesn't have that for the first time. That's with the location of the chip. And then this thing is in a very thin, flat housing that was different aluminum. Remember how they used to bend all the time when they first came out, and they denied that as well? And that combination kind of was a perfect storm, I think. So it's created a massive epidemic, and it has been, really interesting to see the response of the manufacturer, which is a lot of bald-faced lies, which is why I'm happy and surprised for your experience to be exactly what you would expect it to be. Hey, Apple, can I got this problem. We don't fix that, but why don't you go down and find somebody else? Your neighbor does, that's exactly how it should be. All right, let's get this chip on here, and then I think we will be done with this job. So I just put heat on it, and you can watch it find its own spot.
Why? What's causing
surface tension, I would guess. That the liquid pads and the liquid balls will collect together, and we'll be able to see it move.
So if you get it within like half a ball's width, it'll align.
Yes.
But if you're off by one whole row, you're screwed.
That's
right?
Exactly right.
Okay, that's interesting.
And then if I, once I think this one will still more significantly jump up here a little bit. Oh, I think it just maybe did it. Then I can also kind of just nudge dudes, and they'll see how he moved himself. Did you see that?
Yeah. Mm-hmm.
And then I can give him a gentle tap, not on the top, but sort of from the side, like that. See, nudge, nudge, nudge. He comes back to his spot.
Yeah.
Once he's had that sort of imperceptible nudge, then I know I've broken any head-on pillow effect between the pad and the ball. And then that, to me, just that sort of way that flowed, the fact that he moved on his own and kind of just keeping him at time above liquidus of, I don't know, 5-10 seconds. Yep. That's
like glue almost.
It is. It's cool. Yeah.
Now, the air device, it seems to me that you have to get above the solder flow temperature.
Right.
But you can't go too much higher,
right,
or you start to destroy that chip. So it's got
right,
critical control.
Right.
But apparently that chip is pretty robust to be able to take that much heat.
Well,
for that
I
long.
set it at 380. So this one is really a nice piece of equipment. This is the most expensive thing in here. This is a $1,500 JBC hot air rework station. And before that, I used a $600 one from Hako or I forget the other guys. But it's always the same. It's very, very, very clean. But there are guys in the chat that are doing this with an $80 one you can get on eBay. And if you've been doing it for a while, you can read the behavior of the flux, the bubbling of the flux. Mm-hmm. and you'll know if you're too hot or too cold, and you can just kind of pull back and kind of manually, almost like an art, regulate how that chip is going to behave. And when you sit here, and these things are, there's just so many iPhones, they're all the same board, and you just kind of get to know all the chips like your buddies. This is how this one fails. You know, it's the same as, you know, your experience with TVs. You know, that's super fun and totally repairable. And we've trained hundreds of people now from all over the world to do this, and there's absolutely no reason, if Apple makes a habit of saying to the next guy that comes in behind you with a board level defect like touch disease, if they said the same thing, well, you know, there are people out there that repair these boards, which doesn't even occur to them now. You know, that there could be a lot, we could really reduce the footprint on environmental waste and also their sales.
How do I tell people about you and this?
Well, there's
that people like you exist. How do I help you?
You can tell your friends, and let's kind of do this. So we'll go on a little hunt here for the right to repair. So as a resident of New York, where let's kind of take everybody that might be watching this. Let's go to iFixit.com. iFixit is a fantastic group of people in California that are all have a great attitude of, you know, the free repair guide for everything written by everyone. So if you went and you Googled iPhone 5C headphone, they will have, you know, a guide on that, featured guide, and show you, take out these two screws. You don't have the right screwdriver, you can buy it right here, the pentalobe screws. You know, and then this is all very well done. And these guys have done a great job. They've contacted with colleges that have technical writing requirements and said, hey, why don't you help us out? We'll send you a couple devices and you do the teardowns rather than just write a silly, useless technical writing project for engineers. So these guys, usually if you go to iFixit, you can ask a question, and it will usually know that I'm calling here from New York, and it will give me how do I prompt that to happen for the iFixit's main thing that says, hey, New York residents, we need your help? I don't know how to do that. The other place to go is repair.org. And repair.org. This is the group of people that are the only organization that we have as an independent repair industry. This is very new. That is trying to go lobby in Albany to just go sit down and say, hey, guy who's my local guy, this is really not that big of a deal. Look inside this iPhone. You know, my personal iPhone has no screws in it, and I go talk to legislators all the time and just do, you know, hey, look at, you know, what would you think if you went down to the Apple store and they told you, you know, hey, see this piece, you can't replace it. Well, sure you can. Let's just couple screw. That's not a big deal. Everybody can see that's not a big deal and totally replaceable. And going down and having those conversations with, you know, we're even in person at the local level, writing letters. I was stunned to see that these guys, the legislators, really did read this stuff. So here's the right to repair stuff for New York. There's a Fair Repair Act that they like, but they are just not motivated to be passionate about it and pass it this year. It's just too easy to be like, yeah, that's a good idea, but I don't know. It's well, we can kind of do the school lunch bill right now because that's an easy one. And that's how it's been for 2 or 3 years. So this, make your voice heard. Your phone number, zip code as a New York resident, tell your repair story. You know, hey, I went and did this today. And then they read these. When we went to Albany and met with the lobbyist and talked to these guys, they were quite aware of their constituents' voice, which I thought was very impressive, and it made me really happy with the entire process. All right, so let's wrap this up. Anybody have anything that we've really ignored stream? Sorry about that, guys. let's see. Just done TriStar active diode on a 6S with it while watching this video. Great job, Ian Simpson, who I think is in the UK. Next year, Jessa will be CTO of Apple. I doubt it. He wants your business cards to hand out. All right, that's a good idea. Thanks, Mike. All right, let's see if we... No amount of pause will stop the buffer. I can't help it. I've learned the hard lesson. Don't stream when high school lets out. I don't think it's YouTube. Another YouTube live stream has no issues. Let's see. This stream is epic. Great, David wrote. All right. Okay. All right. So I think we're done. Thank you guys for watching, and I thank you, Victor Apple Store, for doing the right thing. I love to be able to say that Apple did the right thing. Fantastic. I rarely get to say that, but you guys did the right thing today, and we have fixed a phone for $50 instead of replacing it for $300. I think that's a win for everybody. And we did some fun stuff. We learned a few things, and we made some new friends, and that's what it's all about. So we will see you guys on the next stream.